All right. Welcome, everybody, to another IAEI News Live. We got Robert from Omaha already in the wings. David Engelhardt in the house. We can start now. So appreciate everybody dialing in. Today, we are going to talk about 2026 code changes. And we're going to continue our discussion out of chapter 1, which, if you recall, we ended, I think the discussion last week, was around 110.3b, I believe. So we're gonna continue our journey in chapter 1 and hopefully finish it up today. All right, guys? So chapter 1, NEC 2026, and it all starts now. All right. Beautiful. We're back. Okay. So we got Willie Snyder in the house. So we are going to continue our discussion. So remember, you can get the changes book, analysis of changes, which I got over here. I got my analysis of changes. Hopefully you have yours too. From the IAEI, I'm going to put that over there for just such an emergency. And then I have the 2026 code. 2026 code book. Get your copy out. I am going to be using NFPA link, which I trust that everybody out there has a copy of or a subscription to NFPA link. You can get to the 2026 National Electrical Code as well as other editions of the National Electrical Code. They made some really cool changes. I'm learning them by by osmosis, but by experience. So in using NFPA link, I'm seeing some of the changes, and I'm liking what I'm seeing. So, all right, here we go. Willie Snyder in the house. We've got, looking forward to this, David Williams. You know, I don't have my glasses on, so I couldn't see it. David Williams. We got Robert from Omaha, Education Power. And we've got some communications. 110.3b was the squirrel in the room. It was, Willie, and it was the squirrel in a room, and I actually learned something, and I had conversations afterwards with other people in the industry because it was revealing. And if you don't know what we're talking about, then you didn't go back and see the last week's IAEI News Live, which you gotta do. Watch that. There was some really good dialogue around 110.3b, as well as everything else, as usual. I try every chance I get. Education Power, absolutely. Okay, so let's dig into this, and I'm thinking we talk about, I don't know if there's much to talk about here in 110.10. Remember, 110.10, for some reason, I don't know why, but I feel like I covered this material before, which I probably did at an IEI meeting. But 110.10 was the section that we always reference with regard to a short circuit current rating. And what we would say is that you can't violate 110.10 when we got to short circuit current values. And I am going to need my spectacles because I am going to use my physical code book. Sometimes, I don't know about you guys, but I am a book person. I like my tabs. I like to be able to open things. So here's my suggestion. Even though you may get your subscription to NFPA link, I think a book is still worth the investment. Primarily because you can go back and forth and do things that I'm doing right now. which I might be able to do online, but I'm not going to because it's easier. So what we used to say in 110.10 was circuit impedance, short circuit current ratings, and other characteristics. Now, they changed it in the 2026 code, and wow, the definitions real. Meanwhile, the definitions is getting larger. So 110.10 is now available fault current. So they replaced circuit impedance with available fault current. And they changed some words in there. So it still means the same, but I think the shift, instead of saying overall impedance and focusing on available fault current, makes a lot more sense. But I would not say that because of the change in 110.10, you're going to do anything different. We got Felix Sandoval, my Shock Week person in the house, straight from Columbia. We got Laurel, and we got research is in the house. So, you know what, Laurel? I'm glad you said that because I don't know what it is. I like the paper copy. I like to search an FPA link, but I still like the book. And I know, financials and whatnot. I like to be able to search across books, but I think there's a place and a world for both. Scrape the white out. Yeah. All right, we got Freddie in the house. Yo, good job. We got Felix, Tech Tuesday. Master Homeowner. Link may be handy to search, but a physical book communicates to each of us. You know what? You're right. And it's the touching it. It's the hands on the book. It's the flipping the pages, the bookmarks. I'll tell you, I could look in some of my textbooks from college. I can remember where on the page, and I could visually see it in my head where it was. I couldn't tell you exactly what words were written there, but I knew generally where it was. So, all right. Okay, so let's do this. I think that was this one. Okay, so I think I would say that 110.10 change, it's not a nothing burger, but it's pretty daggone close to a nothing burger. 110.14, electrical connections. This is a good one. So I think, here's what I'm thinking. Now, again, I'm not going to go through everything that's in the PowerPoint nor in the book. I'm going to hit some of them. I probably should have skipped 110.10, but it was on my screen. But 110.14 terminations. So I don't want to put that down there. I got to put that over here. 110.14, what do we use 110.14 for, Willie? What we do is we focus on 110.14 for terminations. And remember, in the overall circuit, I worry about the conductor ampacity. That's a chapter 3 thing. But the termination and the amount of current I'm permitted to take through a termination, that's a 110.14 thing. But there's even more in 110.14 than just the temperature, because you got A and B that you got to think about. So A is your terminals. That's where we talk about being able to put what types of conductors, because remember, I know I learned this at an IAEI chapter meeting, I think it was, maybe a section meeting, I'm not sure. But, and this was when we introduced fine stranded conductors. There were a lot of debates around, can every termination handle a fine stranded conductor? And the answer to that was no. It has to be listed for the purpose. And I don't know what the industry movement, I don't know if it was in the PV industry. They were using more flexible cables, which the flexibility comes from the number of strands. If I fine strand something, I could make that cable real easy to maneuver. But when I terminate it, I need to make sure that I have a terminal that can handle the fine stranded nature of the conductor itself. And because we want a good connection, good solid connection, you don't want it's not a bad hair day when all the frizz goes everywhere. So So connections, we deal with terminals, we deal with the type of conductors that can be placed under there, whether it be copper, aluminum, dissimilar metals. That's a whole nother. I know the of the last couple cycles, copper clad and the copper and the aluminum people have been clashing their swords around trying to add clarity with regard to what is a dissimilar metal, what is not a dissimilar metal, all that jazz. I'm not here to get into any of that. All I want to tell you is 110.14 is the home where you will learn what you can and can't do. Splices, that we talk about splices in B. C is the big one, which is your temperature limitations. That's where we limit the amount of current that you are permitted to pull through a termination, which then limits the amount of current that you can pull through a conductor, just because it's all a series circuit. And then D is your terminal connection torque values. Remember the torque. We went from from just saying it has to be properly torqued, then to say it has to have a torque wrench, and then we said it had to have a calibrated torque wrench. And then we said, well, it doesn't make sense to put the calibration in there. Hard to enforce. I mean, how do you enforce it? You show up on a job site. How do you do it? But we raised the awareness that torque matters. Okay. In fact, there is a new NEMA video that is out. There is a new NEMA video. Where is it at? I'll put it in the chat. You've got to see it. It is stone cold torque. Every day of the week, twice on Sunday. And I think I wonder if I could just search stone cold torque. Mike Stone, NEMA field rep. Boy, when I put Stone Cold Torque in, I got Stone Cold Stephen Austin. He's all over. I'm just going to do NEMA torque. This new video, I worked with. I typed in torque. I typed in NEMA torque and I can't find it. Mike Stone. Let me search for Mike Stone. All right, so I can't search for Mike Stone either because it brings up a ton of other people. Let me switch my account and I will get you the link. But plus there is a NEMA YouTube site, and geez, oh man, where is it? I can't stand when I can't find something. There it is. I think it's called NEMA View. There it is, NEMA View. I'm going to put the link to NEMA View. So if you do youtube.com/at NEMAVUE, I'm going to put that right here, Control V, enter. There is a video specifically by with Mike Stone, and it is called Stone Cold Torque. You've got to go check it out. It's Mike Stone, and he is our NEMA field representative. You got to go check it out. It's a great video, and it talks about the importance and significance of torque. But we got there because there are some changes in 110.14 and 110.14, and they are removing the word suitable and replacing it with identified. Now, here's the significance of that. And that only went onto the YouTube. So if you're out there watching on LinkedIn or Facebook, you need to go over to the YouTube chat, and I'll put it in the description for this video. It'll be on YouTube. So that'll force you to go over, subscribe to the IAEI's YouTube channel. We are growing leaps and bounds. Our followers on, I don't know if we've hit 25,000 yet, but we are up there. So we may be even higher than that. I'm not sure. I haven't checked since last year, but I'm very happy with the followers and the growth that we've seen on the IAEI's YouTube channel. thanks to Paola, and our marketing person. All right, so didn't realize that receipt was in there. All right, suitable was replaced with identified. Now, identified is a defined term. And if you think about how we use the word identified in other places in the code, handle ties is a great example. We tell you you need to have an identified handle tie whenever you take two single pole breakers. If you're going to say use those on a shared neutral application, we require you to have an identified handle tie on those two breakers. And those two breakers with that handle tie can be used to meet the code requirements in 240 when you're doing a shared neutral application. Or is it 210? Maybe it's both. I don't know. I think it's 210. But in any case, identified doesn't mean that handle tie is listed. It means that the manufacturer has identified it, which goes to our 110.3b discussion. If you didn't see last week's, you got to go check it out. But identified is when the manufacturer's instructions will tell you, hey, if you want to put a handle tie on here, go buy this catalog number. Because you can't put an ABB handle tie on an Eaton breaker or a Siemens handle tie on an ABB breaker and vice versa and all that jazz. So it's important to make sure that we have the right solution for the product. And what they did in 110.14 in the parent text was they, instead of saying and using that word of suitable, which if I went to the style manual, I could probably argue that suitable is a vague and unenforceable term, but identified. Now that's a term that is defined in the National Electrical Code and is used elsewhere in the National Electrical Code and is clear, succinct, and easy to follow and understand, because we've taken the care to make sure that it's clear. There we go, 15,000. There we go, 15,009K, 15.9K subs. That's awesome. I mean, that's just awesome. It's just awesome. Fred says, by using crimp ferrule, would that allow the fine stranded to terminate under a termination that otherwise does not accept fine stranded wire? Ooh, Freddie B. So here's my thoughts on that. Here's my weasel words. Here is my weasel words to get out of any of these tough questions. The first thing I should tell you is that hard questions should have been submitted 48 hours in advance. I could just say that and walk away, but I'm not going to. My weasel words to answer that question is look at the listing. Talk to the manufacturer. I could not tell you what each manufacturer permits or doesn't permit. It would be a good guess in my book to say you're in the right ballpark where you fit those fine stranded conductors inside of a ferrule, as long as that ferrule is listed for fine stranded. And then when you use that ferrule and place that on the circuit breaker termination, make sure that the circuit breaker is listed for that. So you've got two different areas. You've got the ferrule manufacturer, and the ferrule manufacturer may tell you they've tested it and listed it on circuit breakers and other types of terminations. But there are terminations that may require the wire to wrap around. There are terminations that only require or that only permit stranded or solid conductors. Like, for example, I just got, I'm not going to show a brand, but I just got these I'm doing some splicing for conductors in a terminal box in my basement because we're going out to different circuits. Actually, I'm disconnecting what's already there, replacing some wires, and then I have to re-terminate them. And they use these devices. The devices that they used were push. I'm using a different device, but the push devices, and there's a manufacturer that makes those, and when I read their instructions, they'll tell you it's for solid conductors only. So the manufacturer of that ferrule will tell you what you can put in there, and then the manufacturer of the breaker. So I would go back to the manufacturer. I know it's a weasel way out for me on this live stream, but it's actually probably could be definitely the right answer for you. Willie, I never realized how awesome it is to be current on the code changes. I just visited a 4th year class, IEC, and most of them will be tested under the 2020. Yes. 2026. It's unbelievable. And West Virginia, I live in West by God, Virginia. We are just adopting the 2023. So our spring meeting, I just got an email from one of our members saying, hey, when's the meeting? The venue that we use is a school, one of the schools, and we're probably going to do some education on 2023 code to get everybody up to speed, because adoption plays a critical role. And I'm sure if you don't have an NFPA link, you're probably going to have to go buy the 2023 code books. Next thing you know, we won't be allowed to use a handle tie between home line and BR breakers in a Siemens. Oh man, I'll tell you a true story, and maybe at one of the code panel meetings I can elaborate. But I got kicked out of Home Depot years ago because I educated one of their patrons who had a breaker, and the individual who was in the aisle gave them some advice, and I caused that person to go back home and do some homework, which was not good because they lost the sale. And I learned that, they can kick you out of a store for that. Anyway, Josh, the Sparky, thanks you for joining. David Engelhardt says, I recognize your photo. Remind me your name. David, there it is. All right, top of the morning to you. Matt. Excellent. With ferrules, you need the correct tool for those ferrules. Oh, that's exactly right. Crimping and all that, very important part. All right. See this? We're connecting old friends. Yeah. Yep. Okay. Freddie B. Steve. I'm just one good thing. Good morning, Steve. You also can't use a nail, or you know what? I got some pictures of that. Robert, I got some pictures of that. Okay, so 110.14, let's continue on this with our journey. I'm going to skip a couple things. I think the last one, somebody asked about the 110.16 changes. I think 110.16, if you recall, in the 2023 code, I'm just going to call it up on NFPA link. Here's another little word of wisdom. You can open various instances of the National Electrical Code in different tabs. In fact, you can open different parts of the single edition of National Electrical Code. Like what I'll typically do is open up definitions, Article 100 in one tab, and then open another tab and open up a different section, just because I don't want to have to keep waiting. So NFPA 70 2023. All right, so what was I doing? 110.16. Okay, so 110.16 used to focus on, now last cycle, we made a change last cycle. We said, what we did in B was we added this and feeder supplied equipment. That was a big change, because then we picked up 1,000 amp feeder supplied equipment. So you have service equipment 1,000 amps and above that had to have an arc flash label. And what we did in the 2023, this is, you know what? I'm gonna show you something. You come up here, you do open in a new tab, you click on this, and then we can change edition and go back to 2020. So now I've got the 2020, 2023, and the 2026 open in 3 separate tabs. I can go to 110, and I can go to 110.16. You got to love NFPA Link. This is the power of NFPA Link. And look what we had. In the 2020 code, they put this language of these markings. You remember this? I had issues with this. A lot of people had issues with it. This is where we ended up in the 2020 code. In the 2023 code, they said, you know what, we're getting rid of that list because we want to point you to industry recommended practices and standards. NFPA 70E obviously is a great one for that, and we put that in the informational note. But we got rid of that list because for good reasons. We'll go into it was because if you use that list, if you're at surface equipment and you use that list mistakenly for, say, like a PPE category method where you're going to determine your dress based upon those parameters, you are going to be underdressed for the application. It's service equipment. What's feeding it is what determines the incident energy. That's the line side. That's probably a fuse on the line side of the service transformer. If you're lucky that you are not in a secondary network where there is no transformer, but the clearing time is not there for arc reduction, your incident energy at surface equipment can be very high. So you wouldn't want to use that list of parameters to determine your dress. And we fixed that in the 2023 code, got rid of that list, and then said, hey, look, you need to go and specifically go to 70E, go to the right industry documents with a qualified person. And what it said was, in other than dwelling units, in addition to the requirements in 110.16a, which is that there's a hazard, a permanent arc flash label shall be filled or factory applied to service equipment and feeder supplied equipment rated 1,000 amps or more. And it said the arc flash label should be in accordance with applicable industry practice and include the date that the label was applied, not when it was created, because I could create it today and it won't be applied till a few days ago, for a few days later. We fixed that too, so it's when it was created. We'll take a look at the new 110.16 language. And it said that the label has to meet the requirements of 110.21b. All right, so oh man, I don't even want to put that one up there. You guys can read the chat. I love it. Okay, so we expanded, or panel one, I say we, panel one expanded the arc flash labeling requirement to include 1,000 amp feeder supplied equipment, and then in 2026 they just said, look, we're going to leapfrog. We're going to make this so that you have an arc flash label. We got rid of the general hazard thing, okay? And what we did was we said that you have to have a label to be applied on the equipment, not just service equipment. This is all equipment, panel boards, switchboards, switchgear, other than residential dwelling units, okay? Other than residential dwelling units. And 110.16, where's it at? Let me just pull up the language. It'll be easier. All right, so what we said was you need a permanent arc flash marking shall be filled or factory applied to service equipment and feeder supplied equipment. So it says such as switchboard, switchgear, enclosed panel boards, industrial control panels, but such as really expands it. I mean, I could have a disconnect switch if it's feeder supplied. There's no limitations, which is a challenge with this. It doesn't say other than dwelling units. But if it's in an industrial establishment, a commercial facility, that language is pretty generic enough to say, look, I don't have a voltage cutoff, I don't have a current cutoff. If it's feeder supplied equipment, such as switchboards, panel boards, switch gear, motor control centers, meter socket enclosures, that would require, and this is the other caveat, examination, adjustment, servicing, or maintenance while energized. And let's talk about that for a second. So those are some interesting words that are likely to require examination, adjustment, servicing, or maintenance while energized. I have heard individuals say, we always turn it off. So this would never apply because we never work on anything energized. All right? Well, you may say that, so let's just take that at face value and say, okay, what about troubleshooting, right? And what do you troubleshoot? Motor control centers, industrial control panels. So then maybe they say, okay, I'm only talking about panel boards, switchboards, switchgear, transformers, things like that. Here's the issue with that. OSHA, let me find OSHA. OSHA work condition. I can't do two things at one time. So OSHA recently released a letter, an interpretation, I don't know. Here it is. I think this is it. Yes. I have to find OSHA put out a document. Oh, here it is. OSHA releases, this was e-hazards notification. In the bottom line, and I'm going to find this document. The bottom line is that OSHA, I think OSHA would say they settled the debate, sort of, because the act of establishing an electrically safe work condition is energized work. Think about that. Think about what I just said. The act of establishing an electrically safe work condition is energized work. When you turn something off, what do you do? What's the process? Go to 70E. 70E will tell you, establishing an electrically safe work condition, you turn something off, you release all the stored energy, you lock and tag things out, but then you need to measure and verify absence of voltage. That act is energized work because you have to assume it's energized. You've got to dress for the PPE. You've got to dress for the arc flash. You got an arc flash risk assessment. You've got a shock risk assessment. You don't know if you turned off the right breaker or disconnected the right switch. You assume it is energized until you verify absence of voltage. So their argument is that, look, when you do this process, it's energized work. So then you go back to the code requirement that says that is not likely, right? That is not likely, or that is likely to require examination, adjustment, servicing, or maintenance while energized. Well, if you're going to maintain it, even if you're going to de-energize it, it's still energized until you verify absence of voltage. The other area is IR scanning. You can't do infrared scanning while it's de-energized. You need to pull a certain percentage. So go over to NFPA 70B and look at the requirements for maintenance. They'll tell you annually you have to perform thermography on terminations. Well, if I have a panel board and I'm going to perform thermography, what do? I have to remove the cover. It has to be an energized panel. Now you could say, well, Tom, I don't remove the cover on energized equipment. I always turn that panel board off. Then I remove the cover. And then I turn the panel board back on again and I get everybody out of the arc flash boundary. Oh, okay, that's fine. That's fine as well. You're doing thermography, but you've got to be outside of the arc flash boundary. But when you removed that panel and you took the panel cover off, go over to NFPA 70E and find out you're interacting with the equipment. Would OSHA consider that energized work? You haven't verified absence of voltage. You haven't. Yes, you locked and tagged out. Yes, your what do you call that? Your risk is lower, but it's not completely gone. So in any case, that's one of the other. So the first criteria, the first gate that you have is it has to be other than a dwelling unit. The second gate is it has to be likely to require examination, adjustment, servicing, or maintenance while energized. And I just gave you some areas of debate, right? You may have a completely different opinion. Put them in the chat, okay? Comment on the video later if you're watching this, a week, a year, whatever from now. Comment on the video. We'll watch for it. Then it says the marking has to comply with 110 to 21B, which means, hey, it's got to be good, solid, all that good stuff. It has to be clearly visible to qualified persons, okay? And it has to be in accordance with applicable industry practices containing the following information. Now, let's go back to the list. And I saw someone said the list is still there. This is requirement. Yeah, Freddie B says the 110.16 still has the list. Now, this is a different list because the list that was there before just said you needed to know the voltage, the available fault current, and the clearing time of the service disconnecting means. This is much different. This is much different than those three parameters. Here you have to have the nominal system voltage, the arc flash boundary, and then the third one has to be the available incident energy or minimum required level of personal protective equipment. Now, that item 3 is your NFPA 70. You have two options in 70E. You have the calculation method, and you have the calculation method, and you have the PPE category method. Never shall the two mix. So if you're looking at a piece of equipment, you can calculate the incident energy and use it. That's what you have there, the available incident energy. And then the minimum required level of personal protective equipment would be your PPE category method. Now, if you think about the PPE category method, when you go to Article 130 of 70E, there's a nice table in there that'll say what is the equipment. So the way it's laid out, like the first line is going to be, the first line is a panel board, and I believe it's like a 240 volt panel board. The second line is going to be a panel board, which is above 240, say a 480 volt panel board. And you have to meet the criteria inside that table. One of the criteria is the voltage. Another criteria is the available fault current. So if your service has more than, say it's a 480 volt panel board, if that panel board has more than 25,000 amps available fault current at the panel board, you can't use that method. If it's greater than that, then you have to use the calculation method. Capiche? So, and the calculation method, it gets more complicated the further from the service that you get. And the reason I say that is because when you get to the service, I'm not going to say it's easy. I'm going to say that your sources of available fault current are minimal. You got two, downstream and upstream. Your clearing time is pretty defined. Sort of. I mean, your clearing time is going to be dependent on, at the service equipment now, is dependent upon the fuse, which is upstream, which, for all practical purposes, you're probably going to use what we call the 2-second rule, okay? Because it's going to be such a value that it's not going to clear on an arcing fault in the secondary of that transformer. Not likely to clear. I'll always do your homework. But service equipment, I could draw a circle, and my circle of influence of what would influence my instant energy is pretty small. But the moment you get further down in the power distribution system, it gets larger, because now you're worried about configurations. What motors are on, which motors are off, is there a main time main, all that jazz. It can get more complicated the further from the service that you get. And then obviously they put the date. So these 4 labels, I would say the 3 align with NFPA 70E very well. The 4th one, the date that the assessment was completed. Now remember what it said before, the date that the label was applied. I could have an assessment that was done a year. This is going to the old code. I can have an assessment that was done a year ago. The labels were created a year ago and I forgot to put them on, and then I put them on. I've met the code requirement. What this does is it says, when was the assessment done? Not when did you apply the label. It's a significant difference between last cycle and this cycle, right? So that's a critical piece of the puzzle that you need to understand, the why that. Now, the date that the assessment was completed being on that label is not required by 70E. There's a considerable pushback in putting the date on the label in 70E. And the pushback comes primarily from those heavy industrials that, they might have, 10,000 labels in their facility. Maybe more, maybe less. But just think, if nothing changed, you got to go out and change the date on every one of those labels. So those heavy industrials, and there's no exception for heavy industrial. Do I think 2029 we're going to see public inputs on 110.16? Yeah, I think so. But that was and still is a concern of the heavy industrials. And in fact, if you were at the NFPA annual meeting, people stood up at the microphone wanting to nitmam this. And it's that date that really causes heartache. But that date's very important. And the heavy industrials will tell you it's a very important piece of the puzzle too. But what they'll typically require is that you go pull the studies before you do the work. So it's a much more controlled environment than, say, as David Williams pointed out, commercial facilities. Say you go to a school. You may not have that same level of individual working on that power system, nor the resources at that school to have all of that study information and police it, right? But if I'm at a DuPont or an Olin Chemical or a PPG or a Ford plant, those heavier, those larger industrial application installations, especially if they're very in tune with 70E, will have a lot of procedures and policies in place to address that. Not all of them will. I know what you're saying. That's a bunch of, you know what, Tom, but those are some of the arguments and debates that are at the table. I'm not giving you my opinion on it. I'm just telling you there's many sides to this story. All right, so, Steve, yes. You said this is the requirement that I had asked about in the other video that virtually requires a short circuit study for every new installation. Well, Steve, let me educate you here. I think you mean an arc flash study for every new installation, because every new installation, even before this change, required a short circuit study for every single installation. And that has been changing over the last 3 cycles. I'd say maybe 9 years. If you look at in the code, there 408. Okay, let's take a look at 408. 408 dot what? 408.8.4. My NFPA link is much, okay, short circuit current rating 408.6. 408.6. Take a look at 408.6. It says switchboard, switchgear, and panel boards shall have a short circuit current rating not less than the available fault current in other than 1 and 2 family dwellings, switchboard, blah, 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 blah. And it says, shall comply with the following. Item 1, the available fault current at the line terminals and the date the calculation was performed shall be field marked in a readily accessible location in the enclosure at the point of supply. I could go to industrial control panels. I can go to elevator controls panels. I can go to, this covers panel boards, switchboards, and switchgear. Multiple areas in the National Electrical Code are now requiring either a field marking, in some cases a field marking, and in some cases that calculated value has to be made available. So if I'm in a commercial school, if I'm in a mall, if I'm designing a, I don't know, office, any type of office building, strip mall, I have to do a fault current and I have to label equipment. The arc flash label comes after that. So you probably meant to say an arc flash label, but I just used that as a springboard, Steve. Every commercial panel board, absolutely. Panel board, switchboard, disconnect. So here's the other issue. And this is the other issue that I've heard, which I'm expecting public inputs on this. A 60 amp disconnect switch, a 30 amp disconnect switch. Those are feeder supplied. Doesn't have to be 1,000 amps and above because they took that out. It's got to be say it's a 30 amp AC disconnect on a strip mall. That disconnect switch meets the gates of 110.16, and it would need single phase. It's talk single phase instead of 3-phase. So I think I would expect that for the 2029 code cycle, there are going to be some public inputs that put the line in the sand. And one of those lines in the sand very well could be, I know for 3-phase systems, if I go to organization, IEEE, I go to 1584, and I pull up the latest edition of 1584. See, this is the nice thing that you're not going to get elsewhere. You're getting depth. You're getting depth of knowledge right now. And that's what the IAEI is all about, depth of knowledge. IEEE 1584, there's the 2002 edition. Here it is, 2018 edition. The 2002 edition had something a little different, but it was still there. Gosh darn it. Gee Willy Willikers. Golly beef. Hold on. Let me come down in 1584, and I'm going to bring it up. I'm just going to bring up a little piece, just a little piece. There is a scope or a range of model, okay? And there is a value of current below which an arc flash is not likely, is the way they put it. I don't know if there it is. All right, so I'm bringing in this, and I'm just giving, I don't know if somebody out there is going to make this public input. I really don't have a dog in that fight. But it says sustainable arcs are possible, but less likely in 3-phase systems operating at 240 volt nominal or less with an available short circuit current less than 2,000 amps. I don't know about you, but that sounds like an exception. Exception. Systems, 3-phase systems operating at 240 volts nominal or less with an available short circuit current less than 2,000 amps. Equipment operating at 240 volt nominal or less, with an available short circuit current less than 2,000 amps, are not required to be marked. That's just a suggestion, right? So panel board, master, homeowner, a 200 amp load center for an accountant's office. I love that. Yes, it would need to be labeled. Steve, while I highly favor the requirement for detailed labeling, it still seems arguable for financial burden to start up a business. So, Steve, yeah, here's what I think. Here's what I think. Here is what I think. How do I say this? NFPA 70E is an OSHA requirement. So that I don't know how to say it, but if you own a building, a structure, and you're going to energize it, other than a dwelling unit, somehow you have got to address the OSHA requirements. I don't know. I mean, you could try the PPE category method, which the PPE category method could be used to label the equipment. Right? I could go downstream and I could say, what's my protecting overcurrent device? What's his upstream? If it's got a clearing time that is in the values. So it doesn't have to be an economical barrier. I don't think it's going to be free, but I don't know that it's going to be an economical barrier, but time will tell. And that's what I love the process about. Freddie B, overall problem with coming up with the incident energy is very much dependent on what the grid is giving and changes made by the political or the public utility, not under the control of the facility. So there are ways around that. There's an IEEE paper that tells you how to address when the utility doesn't give you the actual fault current, but changes and fluctuations in the current when you have a big hunk of iron sitting there like a transformer, especially in those cases. Especially if I have a fact, man, I don't know if I want to do this now. It is like a squirrel moment a little bit, but here's what I would say, guys and gals. Pull up a spreadsheet, which I have a spreadsheet somewhere on my computer. I don't know, Fred, but if you put the equations in place, you know what? I do have that spreadsheet. And it is right here. If I go to IEEE 1584, I believe I should have my fault current, calculating incident energy. I do have, if you change the fault current on the primary of a transformer, you've got to have a very big swing in available fault current to impact the secondary available fault current. Your secondary available fault current is going to be pretty stable. And XLS. Man, this is the good thing about being live, is we can take this into a lot of different areas. And I'm going to go here. I don't want to say the name contains short circuit. Oh, there it is. I saw short circuit currents. calculator. Here we go. Oh man, this is beautiful. Short circuit calculator. That's 24087. Short circuit. There it is. Education only. Okay, here we go. You ready for this? That sounds like a good song, doesn't it? You ready for this? All right. So I've got this spreadsheet, and I've got this spreadsheet, and I have a transformer. There it is. All right. So if I say we have I don't know, say I have a 1500 kVA transformer, 480 to 208. I don't know, say, yep, 2.2% impedance. The available fault current on the line side, I'm going to make this length 0 feet. I'm going to make it 1 foot. Okay, I'm starting with available fault current of 50,000 amps. Okay, 50,000 amps of available fault current. That's this C16 number. On the secondary of the transformer, I've got 71,000 amps. Now let's change the primary from 50,000 to 70,000. Okay, so now my fault current went up 20,000. Well, let's go back. What was the number? What was this number? 71,000. I got to write it down. I got 71,000 amps, 71K on the secondary. I come up to this top and I change this to 70,000 amps. And I come down, there's my 70,000. And now I've gone to 86,000. So I went up 20,000 on the primary, I think 20,000. And now I've gone to 86,000 from 71 to 86. So let's go to, let's do a Control Z. 50,000. Let's go to 40,000. I dropped 10,000 amps, and I went from 71 to 61. It's 10,000. It's 10,000 amps on the secondary. At a 1500 kVA transformer, 2.2% impedance. If I did 5.75% impedance, I only go to 40,000 amps from 50. From 71. I lowered it even more. So my swing, it would have to be considerable on the primary to get a very significant change. Now, it's not going to be, from an arc flash perspective, you've got to think about everything that happens with regard to lower fault currents can make more of a difference in incident energy for sure. But what I would say is, if you look at, there's a IEEE document that talks about how to deal with when they don't give you the actual available fault current, and fluctuations should not be in the tens of thousands of amps, because then you have other issues with short circuit current ratings and interrupting ratings and all that jazz. All right, Freddie B. Assume infinite bus, Fred. Yeah, you assume infinite bus, but here's the thing, master homeowner. That works for interrupting ratings and short circuit current ratings. It doesn't necessarily work for incident energy, because lower fault currents can drive and will drive higher incident energy. So keep that in mind. Lower fault currents, longer clearing times. Yep, Willie's live, dead live. Doing a calculation, in most cases, it could be calculated in less than 2 minutes. Yeah, I would. In fact, David, here's my thoughts on that. Because you already have to do the short circuit study, you've got to calculate fault currents at all these data points anyway. You're more than likely going to use a software application to get that done, and you're going to have to have a qualified person to do that. If you've generated the one-line diagram and you generated that, the only other missing piece of the pie would be the coordination. But incident energy is based upon the upstream clearing time plus the downstream fault contributions, and you can make some assumptions there. So it's not as hard as people think it is. Presumed dangerous because the breaker is locked off. Absolutely, Freddie B. Testing for electricity condition is live work. Yes. Yep, that's exactly right. 70E, table 130.7, Charlie 15A. Very good reference. You guys should bookmark that one. And if you have NFPA link, you can go look at it. Robert from Omaha. That's right. Qualified persons. Absolutely. You're right, Tom. Was typing on the fly, meant arc flash. I figured you did. But I took the opportunity, Steve. I took the opportunity. Never shall I mess or skip a good opportunity. 70B, 70E, talk about checking existing installations, meaning required short circuit. Yeah, so and that's the point, Robert, from the other previous conversation. If the utility's fluctuating available fault currents, if they're swinging that much, to homeowners' point, if I do the infinite bus, then I don't have to worry about the swings at all, because I don't care what the utility does from an interrupting and short circuit current rating. Arc flash, little different story. Wow, we had a lot of comments. This is good stuff. OSHA changes in November 24 for 50 volts. Yes, absolutely. Less than 2,000 amp fault current. That's what it says. And the reason is, David, because the voltage is important too. I know what you're saying is that's pretty low. That's pretty far. But it's something. All right? It's something. It's a value of fault current, and that's the three-phase bolted fault current value. We got ignition of combustible materials. I get you, Robert. Take initiative and check with utility to see if any changes. That's part of the 5-year, and when you add motors, if you're going to make modifications in the plant and you're going to update your studies, always check with the utility. Double check with the utility, get updated numbers from them at that point as well. Master homeowner, utilities I deal with assume an infinite bus. Yes. So there's still a limit to how much their transformer can provide. Yes. And here's the thing. There's an IEEE paper that deals with that situation. And man, I'm going to have to find it. IEEE fault current utility arc flash. I'll see if I can find it. But there is an IEEE paper that tells you how to address when the utility only gives you an infinite bus number. True. That's why you asked them for the SCC of the transformers. Yes. So you guys are talking back and forth. Freddie B, the Busman app. Yes. Push you. Yep. But here's the thing. I would say, actual fault current values are critical. And as you get further in the system, the dynamics of the power system are going to play a key role. But the FC Squared app is a really good reference for you. Oh my gosh, it's 104. And we got through one section. Holy bejeebers. All right, so it's 104, and I think I am missing... No, I'm not. I'm not missing a call. I got a call coming up here shortly. All right, so I love it when people put a meeting and they give you like 15 minutes. They don't start on the top of the hour. They like start at quarter after the hour or 10 after the hour. I'm going to start that practice. Well, so we got through a few sections in 110, but hopefully you've got a lot more depth in knowledge and you've got some things to look up, think about, think, as Pooh Bear says. Think as much as you can about the processes and meeting these code requirements and the implications of them. It's critical to not just be superficial in your knowledge of the code. Having some depth of knowledge is critical, and that's why the IAEI's documents and these these documents here where we sat around in rooms and we discussed it, these analysis of changes, reference materials, and the resources that the IAEI brings to its members. Become a member if you're not a member. Become a member. Follow the channel, all that good stuff. Willie, thank you for joining, and thank you for all you're doing, and thanks for everybody in this chat to share their knowledge. I really appreciate it. If it wasn't for all of you, I would not do these. This is time consuming if you don't believe me. It is time consuming. It's tough, but I do it because of these Laurel and Willie and David Williams and Robert from Omaha and everybody. I'm surprised I didn't see Michael Hofkin pop up yet. So, and David Engelhart and everybody. So thanks all of you for tuning in to another fine IAEI News Live. I am going to sign off for now. Ta-ta. Since we're on the poo thing, ta-ta for now. All right? TTFN. I'll see you. I'm going to record a session for next Tuesday because next Tuesday I'm out of country. I'll be in Lisbon, Portugal, I think, talking DC power distribution. I tell you what, if you're not ready for DC power, you are not in the know. We're going to have to do some conversations on DC power, maybe get some guests on here and talk about DC power distribution and the future for the National Electrical Code and what you're going to see probably, definitely in a data center near you, but maybe in a commercial building near you. All right. So I'll record next week's session. I don't know when I'm going to record it, but I'm going to report it. All right. Everybody take care. Stay safe. God bless. And please, by all means, do what you can to stay healthy. I will see you virtually next week. Take care.